Hello, everyone. I'm Georg. I'm a lead technical designer at BioWare, and I'm going to present a bit of what we did with Dragon Age and Mass Effect to deal with the incredible complexity of our games. Also, I'm trying to get used to this mic. The nice people from GDC will hand out some forms that you should fill out and turn in afterwards, and please turn off your cell phones. All right, so to kind of give a summary and a setup for why we need development telemetry, and I'll explain what I mean with that in a second, I would like to go back to Jade Empire, a game, probably BioWare's least complex game ever made, released in 2005, I think. We had 7 player characters with unique content and quests for each one of them. 4 male, 3 female appearances with every cutscene recorded for individually for every single appearance, which took most of the disk. In the QA, we had about 10 dedicated story testers that had pretty much nothing to do but run through the story, the choices, and make sure that nothing breaks. In a BioWare game, story is really, really important, and if somewhere in the story scripting there is a break, players are stuck and the game is over. There's no way they can get out. There's no way they can try to wiggle themselves out. So when we ship, we need to be very careful that we're not releasing anything where you can get stuck. Now, our QA department, as representative for the industry, we're 9 male and 1 lucky female. Go ahead. And what does it lead to? Which appearances weren't tested? All the male testers were testing with female appearances, the good old explanation for that everyone knows anyway. And that's bad because, yeah, path coverage, really, really important. So we kind of stumbled on this and we tried to fix it. And these are some numbers, if we go forward, from Dragon Age. It's an just order of magnitude larger game. It is probably one of the most complex games released in recent history. An incredibly large number of words, lots of voice actors, areas, different classes, races, you name it. On top of that, it was also a new engine for BioWare, a new IP. Everything was new about it. And, well, you guys probably know how long it took to make it. There's a reason for that. So with Jade Empire, full path coverage was already hard to achieve. And for some factors like, well, the setup in QA, how many males, females were testing, and so on. For Dragon Age, that's even harder. And we needed to find something that allowed us to ensure that we had full path coverage, or as close to it as possible, with the limited QA resources we have. BioWare is fortunate in a way. We have dedicated QA, people that are long-term with the company, often for 5, 6, 7 years, QA professionals that know our games and that know to work with it. But there's only so few of them. And even if you add temporary outsourcers and so on, our games are freaking huge. So let's just go forward a bit. There's a definition for telemetry that I found on the internet. It sounded nice. It has science and technology in it and all the nice things, but no computers. And then I made up a definition for what I call game development telemetry. And that means really tracking data from your game executable, build pipeline, development tools, to understand where you are in your project and to improve workflow and to help you achieve that path coverage that you need. And it's not from space yet, but also Mass Effect, we could start discussing that. So a quick, everyone knows customer-facing telemetry at this point. It's the big thing. Nearly every major game framework has it built in. It helps us understand how customers experience our game, identify issues post-launch, identify who plays which classes, so we can create post-release content for people, the stuff that they really want. Valve has done some really awesome stuff with it. They can go back, understand how which levels are too difficult, fix these things, and it's just normal to have it in your game right now at this point. Developer-facing telemetry is not so much present or not as organized yet. It helps us identify and react to workflow and pipeline issues. I'll explain that in a bit. It allows us to measure stability, productivity, and efficiency of development. And it is really business intelligence. As a producer, as a person leading a team, it is incredibly valuable to understand how much work can your people get done. Are the tools down 50% of the time? All these kind of things. And measuring them and exposing them is really what I'm advocating. So the solution we build at BioWare, and I'm working for EA, so excuse my selection of logo. We all have to live up for the standards of our company. It's called Skynet. I didn't choose that name, but I kind of liked it. We've deployed it on Dragon Age, Mass Effect 2, and now on Star Wars The Old Republic. And there's some data of what we've been collecting. We've been watching roughly 1,100,000 games played, Dragon Age, inside the company. It was deployed about 3 years before launch. We know the different numbers of machines. It tracks all across the entire EA network. So even if someone in a localization place in Madrid fires up the game, we know about it. We can investigate why the game was just fired up in Madrid or Japan or whatever. And it's a pretty good load of data that has been generated by it. So this is the main interface that people see when they log into the system. It's a web-based application that exposes basically just a lot of numbers. You can see the state of the project as a project manager, where the bugs are going, what people are playing, how they're playing, and generally it tries to provide a kind of drill-down approach. And I'm going to just drill down into this here, which is the running games list. Now, that's not a very busy day. On a busy day on Dragon Age, you would see like 200 people playing the game concurrently during development. But you can kind of see some things. You can see a unique run ID, which is a ID generated when you start the game. And every time you start the game, a new ID is generated, and all the data for that game is stored underneath it. We see the user with their Active Directory name. So it's integrated into the EA Active Directory, which allows us to do single sign-on. People don't have to remember a log-on and so on. They can just go to that page, and we will know immediately who they are and from where they're playing, when they started, which executable they started up, which is important because we're not just tracking the game, we're also tracking pretty much all of our development tools. We're tracking if they're crashing, as an example, which gives us stability metrics, and we no longer have to rely on word of mouth to understand that the animation guys have a really bad time with their tools and so on. We can see how long they've been playing, the build, the localization, which for us is really important because later on we can create kind of a summary and see, wow, the German version wasn't played enough. I'm German. I kind of care about that. And we can drill down further into each of these games. And that is a game session as you see this. At some point we figured out, well, we have all these nice maps in game, and we can track what people are doing in the game. And in terms of Dragon Age, we're tracking on about 6 seconds. Every 6 seconds a beacon is sent to the server that tells it the user is right now at this position and he's in game mode UI, game mode combat, what the major game state is. In this particular session, we can see on the right-hand side that the user transitioned from UI intro, from the intro movie, intro UI, into the single-player campaign, which is incredibly funny given that Dragon Age is a single-player game. And which area they're in this case, the King's Camp night version. If you played Dragon Age, that's where all the towers blow up and everything bad goes on. And we can select the area where the player is in. We can get actually a list that is cut off down there of all the things the player has done. And we're tracking a lot. I'm going to go into that in a bit. And a map of where they have been going. This is really useful also when people send bugs. Again, I will go into that a bit because it gives us context. Context when the bug was filed, what they did before, and so on. And of course, we don't only have that for every single session. We also can aggregate it. We can build heat maps. We can build point plots of it. And if you are a QA manager, you really like this because most of us, if you're dealing with QA, half of it will be outsourced at this point, and you want to make sure that you have your game covered, you have your path coverage. As a designer, you like this because it tells you, well, if no one goes into this area, maybe there's a reason for it. Maybe there's nothing there. Maybe your QA has developed a memory that there's nothing there, and that's the reason why they're not going there. And on the right-hand side, you can see kind of a list of things that we're tracking. It's partially cut off, but we're tracking movement, so you can build kind of the movement map, see where things are going on. We can see where people enter and exit the area. EC warnings are engine warnings. That is an interesting thing. We discovered that pop-up boxes don't work. Shocking. I went to the point of when your character fell through the world or something, you would get a nice pop-up box. Please tell Georg where you fell through the world. He will give you a beer. No one came. So because people got accustomed to it. Like everyone put in code warnings, and they're coming from the executable, they're coming from the scripting language, and at some point people just want to work and they press them away. So at some point in the project, we decided we don't have that anymore. We'll just get rid of all the pop-up boxes. The only pop-up boxes you should see is if your game is unrecoverable and it will end. And they're all getting sent to the Skynet server with spatial information if possible. So at that point, we can select a specific warning like, hey, we're running out of audio memory at this point, and we can plot it onto the map, which will help our audio engineers to go in, check maybe we're using too many sound volumes at that point, and so on. And we assign a dedicated QA resource to monitor these warnings and go track down the programmers, and we get more and more aggressive towards ship to bring them to remove them. So at the end, hopefully, we have very few warnings left in the game, and excuse me, and people aren't bothered with them. Their workflow is not disrupted when they normally work. The same thing for asserts, obviously. We still want the spatial information. We present the user, hey, you asserted, it's over, but we still store it, and I'm going to go into what we do with asserts specifically a bit later. Console commands, that's useful for analyzing play sessions because you want to know when people cheat. If you're working on an MMO like the Old Republic, tracking where /duck is being used, probably a good thing. Game mode changes where people went into combat. That way we can do heat maps of where's combat, where's no combat. Can we design the area more smartly? Can we space it out a bit more? If you remember Mass Effect 1, the Citadel, if you played it, that was probably not spaced so well. There was nearly no combat, a lot of talking. That kind of breaks the rhythm of the game. So this just helps visualizing it and maybe find these things a bit better. Plot flags is changes to plot state. Dialogue starts where you talk to people, where creatures die, where the player dies is kind of important because you can, if you actually visualize it as a heat map, you can kind of get these real hot spots where you have problems in your balance. We tend to put in engine performance metrics like, are you running out of area memory? We're pushing on the console. Are we pushing any of the memory pools over? We want to visualize those because it makes it much easier for the level designers or the engineers to go in and address those issues if they know where they're happening. And as kind of a nice goodie, you can actually click into this map. It will dispatch a console command to your running game, and it will bring your the person looking at it right to that location and even set their point of view to what they're doing. That is really nice when you're dealing with frame rate. Like you could send an event for frame rate being extremely low. You kind of need to know where they're looking because it just helps tracking that down. So I'm going to talk a bit about data visualization. Like raw data is really great, and in fact, even on Jade Empire, I had a lot of raw data. I took the log files from every single game. I uploaded them to a machine, and I was running them at night, trying to run through them. But the problem is no one would listen. It's great. You have this data, this Excel sheet. No one will listen to you, and it's natural. Like it's just a spreadsheet, and if you don't know what you're looking at, there's not much you can do with it. And we have the problem that there's all kind of people in the company, all want different information. So we want to structure it in a way that we can provide engineers with the data they want, and that's probably a high level of detail, like in a technical call stack or something like that. Executive summaries, like really if we have like the previous project director on Dragon Age, he probably doesn't want to read through your incredibly long Excel sheet to figure out what is wrong. He just wants a graph that tells him we're good for ship or we're not. And the best solution I found for that is drill down. So on the top level, we have something like this. It's a very simple gauge that tells our project manager or project director we're good for ship or not. Or in this case, the Xbox and PS3 build integrity for Dragon Age on a specific day when I took that screenshot. And you can kind of see what we took in terms of data and put it into this build integrity metric. We call it like hours played per crash, and we're taking code warnings, remaining warnings, crashes, asserts, kind of things over the number of hours covered by the testers in the company to generate a metric that tells us, well, we're kind of good for ship or we're not, or we're good for this build or not. And if we're going into the red area, we probably have to maybe go into crunch for a bit to figure out, to get back on track. You can click on any of these graphs and you can kind of get a rough idea of what went in there. In this case, we can see the Xbox platform on the one day where it went into yellow. We had 10 hours played, so it was probably a Saturday or something. We generated 1,000 warnings, 2 asserts with one unique call stack, and about 5 hours playtime per crash. The day before, we got 50 hours playtime from our QA, and we didn't crash, so we had about 50 hours without crash. And we all know that in the end, no one is going to ever ship a completely crash-free game, but we're trying to get as close to it as possible, and we're trying to make it measurable. So these reports are interesting. They're really nothing more than SQL statements on the gigantic database that collects all that information. As a nice feature, you can export them to Excel, which makes it really nice for managers to take to meetings and print out if you're one of the older type of people that print things. And you can subscribe to them. So you get an email maybe at the end of the day or at the start of the day or at a specific trigger event, like when we went over a certain number of crashes for that day. Hey, we just went over 50 crashes, something is terribly wrong, investigate. So again, we're drilling down into this call stack in this specific case, and this gives us an information about this call stack. We're hashing the call stacks that are coming in. We're sanitizing them for memory, locations, file path, anything that's machine specific, and then we hash the result and create a unique fingerprint. Managers, again, would probably at this point just bail out because that's not interesting to them anymore, but for programmers this becomes terribly interesting because you can tell this particular crash that happened in that build actually happened before, and we know that it happened the first time it showed up in our database on 8/21. And it's still active. It happened at the day I took the screenshot. We can bring up the call stack, the individual call stack for each single one of them. We can look at other details, but it tells us very clearly we have a new bug, or we have a bug that happened for a long time now. We can assign an age to a bug. We know this has been around for ages. Before, we were kind of guessing about these things. Well, that crash has happened before, but we don't really know. If something is newly introduced, we can immediately dispatch an investigative task to to engineering QA to look into it, because we can prevent things from staying long in our code base. And it also helps us because if we know the first time it happened and you're on a build-based system, you can go into Perforce and you can start pulling out those logs based on the call stack, and you can start assigning blame or whatever you do to people that break your build. So we're drilling down into this specific run, the specific start of the game executable, and we can see who played the game, when it started, when it ended, which build number, when the executable was built, which is helpful because then you can really go and figure out when it was built from Perforce. We can bring up the call stack for any crash that ever happened on Dragon Age. And we can bring up the machine specifics. And if you see where I'm going with that, I could go into the database or through a nice query interface that we have and say, well, now tell me, did this crash ever happen on AMD processors? Or is this specific to NVIDIA hardware or a specific version of DirectX? Gives your engineers much, much more information to quickly drill down where the problem could be. And together with the call stack, it really helps. And finally, we can map it onto a map as a heat map so we can see, well, this crash actually only happens in 2 places. So if you're trying to, for a repro case, QA would probably pick the area where it happened most and run around, see if they can make it happen. Excuse me. Finally, on the topic of business intelligence, we're all working with outsourcers. We're all trying our best to keep them organized, but it's a constant push of information. It's a constant work on your end to make sure that they're covering the right things and so on. So we can create very detailed metrics about what you ever did with our game while you worked on it as a developer. We can tell which areas you've covered, where you've been last, when you've run the game, which bugs you have filed, all this information, which for QA managers managing the outsourcing group is really helpful, right? You bring up a map, you say, well, these areas of the game haven't been hit lately, we assign QA to this, and you can verify the results. You should, the next day when you bring up that map, hopefully you see something, and if not, you can start investigating, talking to them, find out that maybe the load times on a remote system are unbearable or whatever. Business intelligence. So once we had kind of the more detailed information about what happens, what goes on during development, we started improving workflows. And I'm just going to bring up this. This is an industry typical bug tracker. Most of you will probably know it. It has a lot of fields. It has many mandatory fields. Some might be free form. And the general result of that is people will not fill out the fields that they don't know what to do with. They will put in random values because you made it mandatory and they don't like you. And in general, SQL databases like structured data. They really don't like free-form, I did something kind of data. So you pollute your database and you're hampering your ability to know what's going on. This is Dragon Age's bug entering interface. There is 3 fields on it. There is a drop-down, and this drop-down is structured so anyone on the project, not an engineer, not just a QA person, anyone, our CEO, whoever wants to play our game, can hopefully find a category where their bug fits. And if not, they can select general. If they do, whatever category they do, it will assign a person that will get the bug for review. That is kind of our, usually it's the lead QA or it might be the art director or whoever is gating bugs for that department. Even more, if you're typing and we detect certain combination of words, certain keywords, it will alter it. So if I start selecting art and then I type something about VFX, it will change the recipient unless you have overwritten it manually to our lead VFX artist. There is a free-form field where you can type your text. The first line will be automatically converted into the bug subject, and you can select the priority down in the corner. What happened when we did this is a lot of fields disappeared. Like, hey, there's no build number in here. What are we doing, right? We kind of need to know what the build number was. We are retrieving that information from the running game. If you're running the game or you recently run the game and it crashed, the server knows about your game. It knows your login name into the EA network. The game broadcasts that to our server. So we're linking that up and we're going, well, okay, build number, that was the last build you run and you run it on this machine. If you're running multiple games on different machines, you can select which machine you're talking about. And we're locking away all those mandatory fields. What's the localized version? Are you playing German, English? What's your hardware, right? Like if you're filing a bug and you have to put in like what machine you're using, why? It's a waste of time. We know it, right? So we knocked off all of those things and we add them to the interface. The bugs are also spatial aware. You file the bug. I know the second you file the bug where you are in game, about roughly a few meters from the location. And we can warn you about duplicates. We haven't driven this very far, but in theory you could go in very detailed and you could bring up a list of, hey, these are bugs that other people have filed around this location with this build or a build before. Does any one of those match it? Okay, then you don't need to file anything more. Thank you. This is vacation tracker where you file a bug to someone who's on vacation and the bug is of a priority higher than medium. It will actually auto reassign it to the lead who can take care of it. So bugs don't get lost. And you want to pick your categories in a way that they're so easy that people don't have to think about it. One thing we noticed is if people have to think about it, you're in trouble because that already takes away, creates a barrier for them to file the bug. And at BioWare we have a culture of, we have so complex games. We have QA, but it's everyone's responsibility to help. And everyone who sees something wrong with the game, if it's an engineer, if it's a programmer, if it's a receptionist, if you play it and you see something wrong, you file it. There's no such thing as bad bugs. And with this, it's especially true because we still get all the context down to whatever you did in that game before, who you talked to before, who you killed, what weapons you were using, all that information is there. So filing a bad bug becomes really hard as long as you put in something. You can override most of the fields of our bug tracker if you need to, but they're non-mandatory. And lastly, and I think this was actually the most important thing we did, is you can one-click attach a screenshot to the bug. Before, our bug tracker interface required you in a typical web application fashion to save it into Paint, save it in the proper format, upload it into the database, and no one did. And because it was annoying. This one, you click one bug. If the game isn't crashed, we send a console command to the game uploads it to the server converts it and displays it here so you can verify it. Even more, you can, if you select, let's say, pathfinding as your category, it will automatically issue the commands to the game to turn on the pathfinding grid. So the results were within like 3 months, 95% of the project had adopted the new interface because, I mean, why do you want to hurt yourself with those things? We had a significant bug count increase from non-QA, which for us really important. We don't have enough QA as it is. The more people play the game, the more bugs they file, the better for us. We have a huge increase in quality, obviously, because you can always kind of find out what happened. The database becomes much cleaner because all the automatic fields like build are filled out by the system, and that doesn't make typos. And you have spatial information. A nice feature as well is you can run around in Dragon Age. You can have that website open, and as you run through the level, it will display to you bugs that have been filed around your location. When they've been filed, how long it's been, which is great if you're doing bug triages. You're sitting there with a bunch of leads. You're running through the game. You're trying to figure out, are we ready for E3? It's much easier to just run your E3 demo path and see, well, there was this issue. Let's look. Is it fixed? Oh, it's fixed. Great. Not fixed. We can regress it. And so on. And especially bugs that were filed in the art department went up a lot. Because if you're filing a bug about a texture scheme, it's a minor thing at most stages of the project. If you have to save your screenshot and convert it and everything, you're not going to do it. The texture scheme is not worth it. If it's a one-click thing, people will think about it at least. And it gives us much improved reporting over what our fix rate is, what's the bug rate on specific machine configurations, all these things. Achievements. So this started out as kind of a thing. We all know achievements work. There was a talk why achievements don't work, I think. So just disregard that for a second. As a designer, I think achievements kind of work. They teach the player behavior through reward, and it's a cheap reward because it doesn't really cost us much to put the achievements in. They can teach you about deeper aspects in your game. Someone didn't turn off their cell phone. I'm angry. They give you valuable telemetry as a developer, because if you have a achievement, beat Mass Effect as an evil guy, you kind of can see that, well, maybe only 30% of people that play beat Mass Effect and only 10% of those played evil. It gives you actually nice production kind of thing, and it inspires gamer to go to great length to get achievements, like play 100 hours of Mass Effect. They're great. And, well, developers are gamers too. So we did this experiment of, why not? So, yes, I can report they work for developers. They actually work quite well. And they can be used to influence how testers play your game. They can yield balance information, and they inspire a lot of people to play a lot if you do it right. It was actually really helpful on Dragon Age specifically. We had this feature of spell combinations where you can take some spells, put them together to create a completely different effect. So by adding achievements to do that, I can get free testing from everyone because they want that achievement. Great for me as a developer, and hopefully great for the people I'm exploiting with that mechanic. But you can take new features, like we're finished the mage class today, where we put in a major revision. Let's put in an achievement for that class, for the new class features. Go into the deep roads and kill 50 darkspawn with various frost spells or something, and people will do it. So this is one of the pages on our intranet, one of the Skynet pages, which is Dr. Ray Muzica and some of the achievement he got, and you can see kind of some of the achievements we had there. There were a total of like 400 achievements at the end of the project, and I think Ray managed to get like 300 something of them. So it definitely worked for him. It inspires competition a lot. So in the month I introduced the achievements, we doubled the non-QA playtime on the project, which is free QA time. It's money. We had increased bug counts because, of course, I made achievements, file bugs about various topics, right? It got people really excited and competitive. It was actually a morale booster because people would suddenly take the game built home, would play it, and would compare. Like, I made a nice scoreboard because one of the important things is the visualization you need to give people top lists to compete with, right? All the shooters have it. If you go to Steam, you have the nice playout, and people would check like every day and kind of see who's leading the race in the design department, right? Of who has the most achievement. And it taught users about obscure game features, and therefore got more testing out of it. Some people, sadly, stayed addicted, and really had to have them all. Though there were some like programmers or other non-QA people who spend hundreds of hours playing Dragon Age trying to get every single one of the achievements. And what is nice is you can go in and you can put in your real achievements, which are also a bitch to test, and get testing on them. And if they're broken, people will come to you. They will go and, hey, I played this. I played through the Mage Origin. I didn't die. Why didn't I get my achievement? So you can get some free testing out of this. The way we implemented these were mostly on the database. I have I have an aversion of putting anything into the game code. I want to be very non-invasive. So these achievements are nothing more but SQL statement on that huge event database that we have, where I can just go and see, okay, who killed the ogre in the tower using the frost spell, and so on, spit out a list of users and award the achievement afterwards. Completely non-invasive to the game. Later on, we added a messaging mechanism for the real achievements to push to the database so we could verify them. But initially, this was basically free. It was just a bunch of SQL queries you had to write. It rewards desirable behavior. I just have a bunch of examples. So we have this one is from the Old Republic. We had the problem of we catch all those crashes. There's a nice window comes up that asks you what did you do at the time of the crash. No one fills it out. So if you make an achievement for it, people will start filling it out. It really works. This one where specifically we had a nice little event called the Programming Weeks, where we had a week where we basically encouraged the programming department to play Dragon Age. So programmers who would normally not play the game would actually see what they did, what they contributed to the game, and then come back with feedback. And we created a whole set of achievements just for the programming department to compete with, and even had prizes at the end. And you can shame people if you wish to. I'm not going to go into this all too much, but I can tell you this works. Again, more shame. I like shame. It's management by shame. It's really good. People try to cheat. That's unfortunate. They try to cheat your achievements. And they try to outsmart your SQL queries, and they try to teleport around. But one thing you always want to do when you're gathering telemetry about anything people play internally is you want to figure out if they use debug commands, not to shame them, but to understand which data was generated from people that were allegedly playing the game and were doing things the right way, and which games where a QA tester was maybe trying to repro a bug or something like that, because otherwise you're going to jump to the wrong conclusions. You're going to see, someone died here 50,000 times. This is really bad. Let's fix it. No, you don't do that. You need to figure out why the heat map shows you that someone died there a lot, because maybe it was just a QA person trying to debug a crash or something that happened occasionally when a monster dies, and some like kind of just interesting recognition awards of, hey, we at BioWare, we usually have an event over the Christmas break where people can take home their own game or a specific build of a game made by another team in the company and play it and give their feedback afterwards. And we try to basically at least say, hey, yeah, this is one person. You can see it on their profile. They played in the Christmas break. So some practical tips about getting started. This looks all really complicated. There's a lot of data. There's a lot of thought behind it, but it kind of was built very slowly. We started with log file parsing, and we just started adding things. So I'm just going to try to give some of the things we found when we developed this to you guys. So what we found is telemetry systems don't mix well. If you have a external development telemetry systems, and most of you will have that probably at this point, it doesn't mix very well. Because the volume of information that you're gathering internally, and that you can because you have a very small set of testers, is very, very high. If I'm gathering from only 100, 200, 300, 400 machines at EA, I can pull out a lot of data, a lot of detail, and it will really help me understand what people have done in the game, what difficulties they had, and so on. You can't really do that. There wouldn't be enough bandwidth on the planet if we deployed the tracking we had for internal users just to everyone outside. Also, in Europe, you're going to run into a lot of privacy trouble. You don't want to do that. If you build your telemetry system from the scratch, you're not using a middleware or an existing framework, you could probably build one that satisfies both, that detects if you're playing inside your company or outside, and scales the amount of information that is sending. So in general, I advocate staying small. Build a very simple framework. Don't over-engineer it. Don't go, well, we need to add this, this, and this. Just stay small. You want to capture really sequential events. Aggregated data is nice, but it comes free if you have the events that happen. And if you sit down, if you have like long meetings about what you're all going to track, you're not going to ever get done. Be non-invasive. The easier it is to deploy your system into the code, the fewer work your programmers have to do, the better. Like, it's really bad if you're adding your system and then some guy comes over and goes, well, you know what, you just caused 5 crashes with it. People won't like it, they will reject it, and it will just create a lot of hurt for you. So what we did is we went very non-invasive. We're using UDP sockets because they're non-blocking. There's an implicit assumption with that yes, UDP packets can get lost and no one will know about it ever. that's fine. It's just telemetry. It is not mission critical. It is not bad. Sure, someone will miss their achievement and they will harass you afterwards, but really it's not mission critical data. And UDP, lightweight, it doesn't block, it doesn't start locking up your threads if it can't find the server and so on. So it's one of those things. If you can make it very nice and easy and expose it to your scripting language, then tracking all your game events that happen on a design level is much, much easier, and it doesn't require recompiles, which is also really useful because like games like Mass Effect, the compile times can go into several hours if you're actually doing a full rebuild. Reuse your test hooks. Most games, all games, have a console where developers can put in test hooks. That functionality is really useful because you can start hooking into it. Like the example with the screenshot, we had a screenshot command /screenshot in there for me to just open a UDP socket that just pipes the incoming data to the debug console, gave my system full access to all the already built-in commands and all the built-in commands that your engineers will put into your game for free. And if you wanted to, if you want to go a bit further with this, there's no way you can misuse this for automation as well, because you could just send up sequential information or use a TCP socket with actual return values for your console. And yeah, the most important thing is really make it dead simple to add events. Don't force people to recompile if necessary. They should just be able to go in your script code and say, well, the player just killed someone. Let's send an event. And if you create an API, people will come to you. And I mean that in two ways. We have an API for sending commands to the game or to the tracking server, but there's also a reporting API where your application can hook into this and retrieve information. Maybe your bug tracker can hook into it and just retrieve information, what happened before. Maybe you have a specific tool that wants to know if your game is currently running, or what we're doing on the Old Republic. We can identify who has played on a server in the last 24 hours and automatically add them to notification lists about important events about that server, just to manage the email spam a bit. So our technology is actually quite simple. We have the Skynet server. It's a dead simple C# application. It receives UDP packets from PC clients, tool sets, automated test bots, the PS3, and so on. And its only job is to take those packets and mangle them into the database. In our case, the database, a dead simple MySQL database. And the web front end, it's an ASP.NET web app that is available to BioWare users at EA, and external contractors if they have the proper permissions, talks to that database through an API. So the way this works is you start up your game, and the game starts sending a packet to the tracking server and says, hey, Georg is playing, he's playing this build, he's just started it up and he went into this area. The server will write that into the database, and the website doesn't talk to the game. There's no back communication, in fact. None of those clients have any kind of two-way communication with the collector server. They just mindlessly throw large amounts of packets at that server. The website looks into the database when you go in. It checks your username, which is very simple with integrated authentication, and goes, so is Georg playing any games? And it lists me, yeah, he's playing on his PS3 and on his PC. On this build and so on, and it can, when I file a bug, it knows all that information at that point without ever directly talking to the game. So we don't have to inject logic to handle any of this communication into the game that we would have to strip out before launch. If you have an API, you can start building tools and sensors. What I mean with that is we had an interesting technology. Our programmers came up with a really nice way of taking all those Xboxes that were sitting, drawing power and being bad for the planet at night when no one was working, and assigning them tasks to jump into this level, teleport on a 2-meter grid through the level, rotate every 2 meters into all 4 directions and take frame rate measurements, draw call measurements, all those nice and fancy data that your artists will really like when you tell them the performance is bad in this level at this spot. And those tools would use those Xboxes would send that information through the API into the database, and then we can visualize it. We can build heat maps. We can dispatch alerts in the morning that half of those Xboxes tasked with jumping into a specific level failed, and so on. So some things I already went into it. I prefer UDP. There's really no rule why you shouldn't use TCP, but it's faster as long as you can accept that your telemetry data will get lost along the way. I like C# for rapid application development, but again, you could write a Python or Perl script or whatever to do most of these things. A nice touch in C# specifically is your ability to compile scripts at runtime. So what we have is when a packet comes into the server, it has a 2-byte identifier at the start that tells it which packet handler to invoke. And these are scripts that are getting compiled and downloaded from a database when you start up the server. So we don't have to recompile the server software ever to handle new events. It also allows us to be very flexible. So when a designer comes and goes, I'm really having a hard time figuring out how people beat this specific boss. Could we add a triggering event to the game that when this specific thing happens, I get an email? You can create packet handlers that very quickly handle this information and push the email to the designer, because basically the entire power of the .NET framework with all the built-in libraries are available to you. And one mistake I made the first time around when I built this system is all the events went into one table. Not good. Tables, depending on the database software you're using, and I'm sure the Oracle people are smiling now, is when you have enough rows in there, your web front end gets terribly, terribly slow. And at some point, if you're going towards like the hundreds of gigabytes of data, you're not going to be happy. So what we do is we have a different set of tables. We have a way of routing events to different tables. And another mistake we made the first time around when we gave this tool to the Mass Effect team was everyone looks at it and goes, hey, it's cool. I can track when this happens and this happens. And we got an incredible volume of data into the database. And then they came back, well, your stuff is actually shit, because when I open that page, it takes 2-3 minutes to load. Not surprisingly, if you have a lot of data in your database. So what I'm doing is when you're registering an event with the server, you have to register it. You have to say how long is that data kept. Because really, if you think about it, levels change. If you're at a certain phase in development, level layouts change very quickly. There's no point in retaining movement data for users that have played on an old version of the level. So we say after 20 days, generate a bunch of aggregate data and throw out all those movement events. So we keep the database lean. In our case, we used a character delimited string as the protocol. Really simple. It's a tilde character that breaks up the different fields. Mostly because all scripting languages on pretty much any game we work with can support sending strings and concatenating strings. While expensive, depending on the volume that you're working with, are not that bad. And it makes it that simple for like even non-technical people to add events if needed. And we don't have support for fragmentation because we're dealing with the internal EA network. Everything is really nicely routed. Our IAS people are awesome. And we have very little packet loss and fragmentation. If you wanted to start working with a lot of people offsite and you don't have those steelhead or whatever they're called, VPN equipment, you probably have to start thinking about things like fragmentation a bit. Useful data sources for this. Obviously, the game client and server, you want to get events from those. Call stacks for crashes, warnings, movement events, save game screenshots, the one-click save game, very helpful. Performance timings, your tool set. You want to know the startup times of your tool set and the usage patterns. There's 2 reasons for that. A, you want to see if people are crashing, if they're forced to load your tool set a lot and so on, so you can start investigating. You can tell the tools team to look into it, but you can also see usage patterns. And this is the first project where I can prove conclusively that after the third week of crunch, and we all always say that, but after the third week of crunch, you can see on the graphs how the lunch times are getting longer, how the coffee break starts appearing in it, and how dinner breaks and so happen. So you can verify the information that you have. Wikis, SharePoint, there's a really nice thing that you can do is you can send console commands to your game. There's no problem with hooking up like a page on your website where you can allow people to click on a link to execute a console command. Really useful. I could send out a mail to everyone, go, hey, I just implemented the Ranger with these 4 abilities. All you have to do is go in the game, click on these abilities, and they will be added to your character, and then you can play them and send me feedback. Your bug tracker, obviously, you want to know all about your bug tracker. It's probably the most important tool on your project. It measures the general health of your project. And you can, again, look into usage patterns as well. You can see which areas are more bugs filed in. Maybe there's certain areas or levels that are specifically bad in your game that you need to focus attention on. Or it helps you before E3 to decide which of your levels you're going to go and show off. You're an IP-enabled coffee maker. Again, going back into the crunch thing, if you have that information, you see that maybe the coffee consumption went up. Maybe something is wrong. Maybe your people are stressed and you need to look at it. Twitter. Like now the HR people probably go, yay, now we can finally track everyone who's using Twitter. We use it to actually look at like our PR timeline and kind of to see maybe how is that E3 trailer, how did that E3 trailer go? We see I think one of those spikes is the Knights of the Old Republic cinematic trailer, which was so awesome last year at E3. So you can kind of measure your buzz, and we're actually storing every single tweet. Anytime you say Dragon Age on Twitter, I know about it. It's in my database, and I will. So this is an example for toolset visualization. Something bad happened there at 5 o'clock, because each of those horizontal lines is a toolset session of either the toolset or I think the end user toolset, depending on color. And something really bad happened there because all the sessions stopped at once. If you have your server, everyone connected there, and you can measure this. You can dispatch an email to your tools team immediately when that happens, because hey, there's like 100 people that just stopped working. Something is probably could be a power outage as well. So you can measure how long it takes your team to get back up after a power outage, or how much damage how much man hours did you lose through that fire alarm that happened because someone burned a toast in the kitchen. Happens, right? You can get stability and usage metrics about how many crashes you have over your specific client hours, over parts of your tools, your actual game client. You immediately will see that, when you have a bad build, because these things will spike. And you can start building a memory in your institution of certain patterns, like when are specific days when we're not getting a lot of man hours in because maybe everyone is on vacation or Halo released or any of those things, right? And you can start planning for them so you don't make the same mistakes in the future. So where do we go from here? The general idea is I want a giant database that takes all the sources in your company, all the data sources you have in your company, your vacation tracker, everything you can think of, and index it. Game data, actually, we're doing a lot of that on Knights of the Old Republic. We're going in and we're resolving a lot of game data, information about every creature in game, every area in game, all these things get piped into a database, and then you can correlate it. Not only can you give people a list of which creature killed the most people, you can actually drill down into that creature immediately and start looking at what's the stats on that creature, what's the weapon, and so on. So the path your engineers have to get to the information, what could be the root cause of a specific behavior or problem, gets much, much shorter. Make it all searchable and viewable, and I'm really a huge fan of making things easily accessible, like an easy-to-use web interface, Don't use like, I don't know, sans serif, Courier fonts and just an ugly thing. Presentation helps a lot. Especially managers will not like web pages that look all that technical, and they will not use it. If you make it easy to use, and it's not that hard these days with the tools out there, people will use it. And once they realize how much it helps them, they will continue to go back. Retain information on, like, put in telemetry on your own interface. Figure out which pages people are looking at. When we had a lot of assumptions when we started this thing, we could use this for mostly design balancing and so on and so on. When you start looking at what people actually use your page for, you can change your focus. You can go, but actually people are mostly looking at warnings. They want to know about stability, so let's invest a bit more time in there to get that in. Retain historical information. Build a memory for your organization about how your work patterns are, what your problems are, how do your projects, we have this running on several projects now, so we can look at the bug curve for Mass Effect before ship, for Dragon Age before ship, and we can start understanding how a BioWare game, how the bugs are actually being fixed, so we can make much, much better measurements of what our velocity will be or how many QA resources we will need to get our game fixed. Push information back into the game. You can send a message. We did this on Dragon Age a number of times. We had some terribly broken builds, and they were still out there. We could tell that people were playing them because we see it on the tracker. People would file bugs on them, and we don't like that. We don't like dupes. So what we did is we used the console command functionality. Whenever someone connected to the server with a specific build, we would bring up a message in-game. Your build is terribly broken. Don't bother us with bugs. Just update. Or your DirectX driver is bad. You will crash if you continue from here. Please update. Right? So you can push information into your company. And so I have this. This is an example from what we have on Dragon Age and the Old Republic now. It's a project search engine. It's all the knowledge, all the databases we have connected. I type in vials, I get the areas we have, and from there you can drill down into what into that area. You can look at all those heat maps and fancy things. You can find call stacks that were dispatched in that area, crashes. You can find open art bugs in that area. You can find tweets if anyone talked about that. So I could be like put in my name in. I would see my user profile. I would see every bug I ever filed. I would see every crash I ever experienced, every computer profile I ever used in the company, the game with, and everyone who complained about me on Twitter. So I can find them. And all the save games I made. So that's it. Kind of a prop. I hope this was valuable. And most importantly, this is not in the shipped version of the game. There was a mistake. There's some scripts out there that seem to send emails. They don't. All this is nicely if-defed. None of this functionality is in the game, and you should never do that. You should always make very sure that your final ship builds do not have any of that functionality in there, because also you don't want your game client out there with an open console port where anyone can send commands to. That's just asking for trouble. So, all right. Thank you. Remember, please, to fill out those cards and give it to the friendly people back there.